button. If you get the idea, I think that there might be no problem to use the icon for your project also. If we have a time, before we end, we will a little bit talk about the plan for your final the project as well as the final exam. Okay. Before we start, as I email you, those who are interested in the new concentration, big data and data analytics, so you can submit the form after fill out. You should complete the 551, 552, this one, 651 and 652. And that will be applied to your the major. So the concentration, name of concentration will be added to your the major. But this time only the master student will be qualified for this one. I think that we have the 2 or 3 students you apply, and I think there might be another. So why don't you before the semester ends? Also, if I think you asked me about the cloud data certificate exam, I got the response. So I got the email. Then they will provide a 50% discount for the student who have the it's a cloud data something program. I cannot remember the name of the program. So there is a CAP program between the cloud data and university. So UB is one of them. So those who are attending and the course is supported by the CAP program will get the 50% benefit. So I think one of the representatives from the cloud data will contact you. So I inform to them your email. So she will contact you to give the instruction. Okay. Is there anyone who are interested to take the cloud data certificate? Then let me know whenever you are ready. Okay. Any question? Okay, so you can start.
Okay, good evening. I will talk actually today about the social user mining research, which is kind of user profiling in social media network, and this is actually based in multimedia data mining. So this is, before I go to the outline of the presentation, I would like to share some information with you so you can get some clue about this kind of research. Okay, so this is images actually uploaded to the Flickr website by user. So the question here actually, by looking just to these images, can we indicate anything about the user?
Yes.
Like for example, can we tell if this user male or female? So how? So one possible way may be just by looking to the colors of the images, because the male and female user actually they have different color preference. So this is one possibility that we can indicate something about the user based in his data, in this case, which is the images of the user. So, and how about if we add another kind of data, which is the textual information, in this case here, which is the tag that provided to the images by the user. So the same question, can we indicate if this user male or female by just looking to the word or the keyword of that user? So in some cases, yes, that is possible, because also the male and the female vocabulary sometimes is different to some level, and we can use this different to identify, for example, the gender of the user. So by using different kind of multimedia data, in our case here, the images and the tag, we may have some clue about the user, or we can discover known information about the user based in multiple type of multimedia data. And we have another example here. This is a tweet from the Twitter website for T user. So another question here, by looking to the first user, for example, can we indicate the location of the user?
Yes.
How? So this is a word that there are some words that maybe have indicate something or indicate location information about the user. So this is another example of using the textual information to mine or to discover some knowledge about the user based in the information that the user provide. So we'll give introduction about this dissertation by looking for the problem statement and the motivation, and I will briefly talk about the related work for the social user mining research, and also I will talk about the mining framework that we propose through this dissertation, and we'll talk about the data assemble module, and also we'll talk about the data integration based in two different approach, and we'll talk, if we have time, about two mining application that also we proposed, and we'll end with the conclusion of this dissertation. So in the recent year, actually, we have witnessed an increase of the number of the user that use the social media network. So for as 2010, for example, here the number of the user actually was less than 1 billion. In 2014, actually, the number of the user actually has jumped to almost 2 billion user. So these users actually, of course, they are sharing some information through the web and different social media platform, and this increase actually of the number of the user has generated an increased amount of data, or huge amount of data. For example, in the Flickr website, the user in Flickr actually they produce more than 4 billion images, and the Facebook actually, the user in Facebook, they produce the same amount of data each month. And also according to the Twitter, the user in Twitter actually they produce about 500 million tweets per day. So this is very huge amount of data, and this data actually has opened a new opportunity to the researcher to go further actually and do some research like what we are doing here, which is the user profiling, or for example we can also do an event detection or any recommendation system. So what's important actually in the social user mining research, not just the method and the tool to organize and manage this kind of data, but also the method and the tool to discover some unknown information or hidden information about the user based in this kind of data. For example, discovering the gender of the user. This is will be helpful for any recommendation system, and this actually will have some challenging, because first of all the social media data are unstructured, and also there is some privacy that usually the user do it with his or her profile, and for example they try to hide some of their profile information where will be difficult to have access to the user profile information. So the research problem actually, I will start with defining the social user mining, which is to discover known information about the user, and this information actually will be discovered based in the data that the user actually, or the public data that the user provide profile in the social media network. So whatever the user actually marked as public, we will have the ability to have access to this kind of data and discover any information about the user based on that data. So this is actually will not be an easy task because first of all it's going to be very hard to make a good structured database in this kind of data because this will require a lot of data pre-processing, and also it's very important to identify the subset of content that will be most useful to discover the user profile information. So for example, we have in the Flickr website, the user actually has an option where they can upload images to their account. At the same time, they have an option where they can mark some images as their favorite image. So of course, in this case, the favorite image of the user actually will reveal more information about the user compared to the his general images. So in this dissertation, actually, we tackle the challenging of the social media data to discover unknown information about the user based on his or her public data. So I will give also three different definitions. The first definition is the social user or the social media data. So D in this case actually is a multimedia document or a multimedia data that created by the user in the social media network, and D in this dissertation actually or this work considered to be the basic item and of the social user mining research, and D will have multiple multimedia content. For example, we have the tweet here in the Twitter. This is one example of the social media content, and also we have the photos and the metadata in Flickr. This is another example of the multimedia data. The second definition will be the social user. So you actually is a user who can create social media data. DU, where in this case actually is the n number of the user profile user attribute that describe the user profile information. As an example of that, we have the user in Flickr will have some attribute that can describe the user profile information, such as the user ID or the location or the occupation of the user. So there is a different kind of attribute actually that can describe the profile information of any user in the social media network. The third definition will be the social user mining. So giving a set of multimedia or social media data that we defined already, DU, that relevant to a specific user U. So the social user mining will be the process to discover one or more missing attribute about this user based in his data, and there's a different kind of attribute that could be a good candidate to this kind of research. For example, we have the gender attribute or the location or the occupation. All of these attributes actually, or each one of these attributes could be a good research topic or to such kind of this research. So in this research, we focus on two types of attribute. The first one, which is the gender of the user, to find the gender of the user, and the second one actually the location, where to also to predict the location of the user base in the data that the user provide. So the scope of this research, actually I will start first with the data source. So for the data source, actually we use two types of data source. The first one, which is the Flickr, which is one of the most popular website that designed to image sharing and management, and also the Twitter, which also known as a microblog website. And for the data models, actually, we use first the user tag and the user tweets as textual information, and we use the user photos as visual information. And to manage these kind of different data type, actually, we also introduce a new method to integrate between the text and the image data for the social user mining research. So the objective of this research actually will be first to provide the proper method to understand and manage the social media data, and then to discover known information about the user, and this information actually will be discovered based in the public data that the user provide, and also to evaluate the a proper multimedia feature for the social user mining research. So the motivation actually behind this research actually first come from the massive volume of data that provide in different social media platform. So it's very important, or it will be very interested to discover known information or hidden information about the user in social media network. So we are motivated by the fact that using different kind of data can play a key to enhance the social user mining research in general. So this is actually will have an advantage not just for the user themselves, but also for the business and the consumer as well. So for example, by discovering the gender of the user, actually this is can be helpful to any kind of online targeting or any recommendation system actually. So the contribution of this research actually first we propose a novel mining framework for social media mining, and this framework actually based in two different application, or based in two different mining application. And then we introduce a data assemble model to manage two kind of data, the textual information and the visual information. And also we introduce a new data integration method actually to integrate between the textual and the visual data. So I will talk very briefly about the related work actually. So for the related work, the main goal here in the related work actually to survey what kind of data type that the previous research use with respect to the social media data. So we divide this survey based in three different aspects. The first aspect is the content-based social user mining, where we survey based in the text or the textual data and the visual data. And the second aspect, which is the semantic-based social user mining, where we survey based in the semantic content of the images and the semantic content of the video. And the third part, which is the data mining technique that used to mine the social the social media data, and this is actually done based in the supervised approach and the unsupervised approach. So this is an overview about the content-based social user mining. You can see here what kind of data unit. This is the most important part to us that the previous research used. And also this is the semantic-based social user mining based in the images and the video with different tasks and different method. And this is the data mining technique that use also to the social media data actually. So the main point that we can conclude from the survey that most of the previous research actually has focused on just one type of data. Some research they focus on the textual information, while other they focus on the visual information. So in this dissertation actually, our main goal actually to use a different kind of data, which is or the both kind of data, the textual and the visual data, and we provide actually a method to integrate between these kind of data actually. So for the mining framework, so to also improve the quality of the social user mining research, we propose a mining framework, and this framework actually has three main components. The first component, which is the data assembly model, and the second component, the data integration model, and the third component, the mining application. So for the data assembly model, this is focusing on collecting the data from the social media network, and also we collect different kind of data. First one, which is the ground truth data, and also the textual and the visual data. And for the data integration, we propose two different methods. The first one is content-based data integration, and the second one, which is new compared to the state of the art, which is the semantic-based data integration. And also we introduce two different mining applications based in two different data sets. The first one is the gender classification, and the second one the user location. So this different also from the others. This framework actually can work for different social media platform, and also different kind of type of data, as well as different mining application. So I will start with the data assembly model. So this is the data assembly model that we propose. So the nature actually of the social media data actually are different from the traditional data that we use usually with the data mining, because the social media data actually usually are noise, and also noisy and big, as well as in some cases incomplete and unstructured. So to overcome these challenges, actually we propose this mining or this assembly model to collect the data from the social media network, where we have different method of data collection. The first one is the APIs, and the second one we use implemented the crawler, and a different kind of data also, and the pre-processing and the representation, and I will talk about each part separately. I will start first with the data collection. So for the data collection, actually, we collect three different type of data. The first one, which is the ground truth data, and the second one, the textual and the visual data, and the third one, the semantic data. So for the ground truth data, actually, we implemented the crawler using C#, and this program actually based in the web query, where we have the URL of each user, and each user actually in Flickr, they have a unique ID, and we got this ID from another benchmark data set, where we have 215,000 users that we have their ID, and we use this ID actually to access the user profile information, and we extract some attribute from the user profile. And this is an example of the user profile in Flickr. This is my profile page actually, and this kind of attribute that we are targeting actually here. And this is the result that we get for the data collection actually. Different attributes. Also, for example, here for the gender, we have up to 148,000 users that we know their gender actually, and later actually we implemented an application based in based in the gender attribute. So the second part of data collection, which is the collection of the textual and the visual data. So we collected two types of data. The first part, which is the visual data, represented by the favorite image of the user, and also the tag data, which is a keyword that assigned by the user to the images. So this part actually done by using the Flickr API, where they offer actually a platform for the developer to have an easy access to download the data from the social media network. And for the textual information actually, we collected the tag of the user, and each user actually will have up to 300 tag. And for the visual data actually, we use the favorite image of the user, and each user actually will have up to 50 images. For the semantic data, or the collection of the semantic data actually, the main purpose actually of using the semantic data actually, in this case here we are trying to improve the quality of the tag. Yes, tag very important and assigned to the images by the user, and usually reflect or the interest or show the interest of the user in the images. But in some cases actually the tag may come ambiguous and also offer personalized actually. So to overcome these challenging and improve the quality of tag, we propose to use a semi-automatic tagging system called a KW, and this system actually works based on the visual similarity of the images, where they have actually up to 15 million images tagged in their system actually. So what happened actually, we query images, like for example here, this is the KW system actually, and this is the images that we query to the KW. So what will happen, this system will retrieve similar images to this image, and then based on these similar images actually, we will suggest a group of keywords for these images actually. So what we did actually here, we query the images for each user one by one, and we collect the keyword for each user based on his or her 50 images. So this is for the data collection. And for the data representation actually, this research actually refers for the textual data actually represented by the tag of the user, where each user actually will have n number of tags. And for the semantic data, this is represented by the keyword that we collected from the KW, where each user actually will have n number of keyword. And for the visual data, we use or represented by the image of the user, and we use two different features. We use first the hue histogram, which is based in the hue value or the color distribution of the images for that user, and each user will have also a number of hue histogram. And the second feature, the hue in bag of word, which is the same concept with the hue histogram, and this is just we focusing in the top two colors, and each user also will have a number of hue in bag of word, and I will give an example later about each one, how we implement that. The other part we'll talk about, which is the data integration. So the main goal here in the data integration that we are trying to integrate between two different kind of data. The first one, which is the tag of the user, and the second one, which is the images or the favorite image of the user. So we propose two different approach for this task. The first approach is the content-based image fusion, which is based in the content of the images, and the second approach, which is the semantic-based image fusion, which is based in the semantic content of the user images. So this is the content-based image fusion actually. So we have the user tag. So we integrate between the user tag and the user images. And for the user images actually, we calculate the hue histogram and hue impact of word, where each user actually will have ft, which is in number of the feature of the tag for that user, and also FHS, which is the in number of hue histogram, and also FHBW, which is in number of hue impact of word for each user, and we will combine these feature as one feature factor. And the second approach, which is the semantic-based image fusion, and as I mentioned, this is a new approach. So what we did here actually, we integrate between the user tag and the semantic content of the user images by using the semi-automatic tagging system, where we produce the keyword for the user based in his images, where each user also will have FT, which is in number of the feature tag, and also FK, which is the in number of keyword for that user. And also we combine these two features as one feature factor. And I will also show our first application how we implemented these two kind of data integration. So now I will talk about the mining application. So we introduced two different mining application. The first one actually is the gender classification, and this application based in the data set that we collected from the Flickr, and the second application actually the user location, which is based in another benchmark data set from the Twitter. So I will start first with the gender classification. So the problem in the gender classification that we have for the user U giving his data DU, which is the tag and the images, we try to predict the gender of the user first in his first in his tag, and then based in the images, and also based in a different combination between the tag and the images. We use two classifiers for this task. We use the knife Bayesian based classifier, and we use the support factor machine classifier. So we have the class G, which is the label that have the user or the gender label that have the G1 and the G2 with the probability of G1 and the probability also of G2. So we assign the class G to the Flickr user based in his feature factor DU, where DN actually represent the user data and can be for the giving the feature factor DU for the specific user. We try to assign the class with the maximum probability to that user actually. And this can be formed using the Bayes theorem as in this equation here, which is to predict the most possible class giving the feature factor DU, where each user will have actually in number of feature of his or her data, and also for the support factor machine actually will map these feature actually to the high decimal space. This implementation actually done based in two different approaches. The first approach is the content-based classification, and in this approach actually we use the tag data as well as the image data. Tag, actually first I will start with the tag. Tag, as I mentioned before, reflect the interest of the user or what the user can see in their images actually. For this part actually we assume that the tag vocabulary between the male and female user are different to some level, and this level actually can be used to determine the gender of the user. So what we did actually first, we built a dictionary, and this dictionary actually will have the male and female tagged vocabulary, and the main purpose of building this dictionary actually to see the frequency of each word or each tag that used with the male or female user. So we have the tag, and we have the male frequency, and we have the probability of male giving that tag, and also the female frequency and the probability of female giving that tag. And for the image data, we use two different features. So this is an example of the first feature, which is the hue histogram. So for each user actually, we calculate the hue histogram based in his images, and will assign the numeric value as feature for his histogram, and also for the hue impact of word actually based in the hue histogram here. But in this case actually we focus just in the top two colors. Here we have the red and the blue, and we assign the value 1 to the top two colors and 0 to the others. So this is for the image data. And this is the content-based experiment result actually. We have two evaluation metrics. We have the accuracy and we have the F1 score. And for the evaluation purpose, we group the user to 4 groups. The first one is the true positive, and the second one which is the true negative, and the third one the false positive, and the fourth one is the false negative. For the feature actually, we have the tag feature and the hue histogram and hue impact of word, and also we have a different combination based in these three features actually. So based in this result actually we can see here the tag actually giving the higher accuracy, which means that the content of the images actually has not improved anything. When we add the content of the images with the tag, the accuracy actually in some cases dropped. So from this point actually where we start about thinking about another approach. So since the tag here giving the higher accuracy, so why don't we think about another approach where we can improve the quality of the tag? So we done this actually by using the semantic based approach. So the goal of using the semantic based approach actually to improve the quality of the tag, and we run this first by collecting the keyword for the user based in the images or the favorite image that we collected from Flickr. So for this implementation actually we use two kind of data. The first one is the keyword data, and we implemented the keyword also the same way that we implemented the tag information in the content-based approach. And the second part, which is the keyword and the content-based data, where we implemented this kind of database in the new integration model that we proposed earlier, which is based in the keyword and the tag of the user. So this is also the semantic-based experiment result. We have also different evaluation metrics. We have the accuracy, we have the precision, and we have the recall, and we have the F1 score. And in terms of the feature, actually, we have the keyword, and we have the tag feature, and we have also the keyword plus tag. So for the classifier, actually, we have the naive-based classifier, and we have the support vector machine. And you can see also based in this result that the keyword giving the higher accuracy, this is a good indication that we have proved the quality of tag compared to the tag by using the semantic-based approach. And even when we combine the keyword with the tag, still the result actually better than using the tag itself. So from this result, we can conclude that the semantic-based approach, the new approach that we propose here, actually has outperformed the content-based approach. So this is about the first application, which is the gender classification tool. So now I will talk about the second application that we propose here, which is the user location. And this application actually pays in another data set, which is a bunch market data set. So the problem in this part actually can be defined as for the user, you in Twitter, giving his or her set of tweet messages, as well as the group of candidate city. We try to predict the city that most likely will be the home location of that user actually. And for this, for the algorithm actually we use the Gaussian matrix model. So this is an example actually about the tweet by location. So for example here, this is the user from New York will tweet something like this one, going to Bronx Zoo tomorrow. And I already give this example in the beginning of this presentation, where based in this tweet actually we can indicate that this user actually maybe he's from New York City. So this is the concept of the tweet by location. So for the this is actually for the conditional probability under the Bayesian rule. Actually, we have three different models. We have the language model, which is the maximum likelihood estimation, and can be formed by this equation. And we have the special word use model, which is the same with this one, where we replace the product of the probability by the log of the sum of the log of the probability, and and here we have the Gaussian matrix model, and this model actually, this is the equation for the Gaussian matrix model. So each word in this model actually appear as a data point, where, for example, if the word tweet is like 3 times, so we would have 3 different points for this word. And this is actually it is the bifurcation Gaussian distribution with the density, and K, as I mentioned, it is the number of components. In our case, it's going to be number of cities. So what we did here actually, we introduced another approach, which is called the local word selection. So of course, I mean, not every word you can see in the tweet that have an indication about the location. So for example, even if the user tweets something like the restaurant or downtown, even if the user tweet this word, for example, 1,000,000 times, so it's going to be very hard to assign a location based in this kind of word to the user. Where if the user, for example, tweet the word really, so this will have a high probability that this user maybe he's from Philadelphia. So the purpose of using the local word selection actually to reduce the noise as well as to speed up the competition. So we propose actually two different approach or two unsupervised method to select the local word. The first one, which is the non-localness, and in this method actually we select the word that most likely this similar to the stopping word, and after that we estimate the special word used for each word as well as the stopping word, and we find the similarity between the two words by measuring the distance between them. And for the second method, which is the geometric localness, and in this method actually we consider the word as a local word if this word actually has a smaller number of city with high probability score, as well as a smaller average inter-city geometric distance among those cities that with the higher probability score. So this is an example of the top 300 local word. You can see here that has an indication about the user. For the experiment actually, so as I mentioned in the beginning, we use a benchmark data set that collected by Chen et al. In 2010 and 2010, and this data set actually divided first to the training set where we have 130,000 users with 4 million tweets, and this is based in the city level location. And for the testing set actually we have 5,119 users, and each user actually in this case with 1,000 tweets, and this is also in the this is in the location coordinator, which is the longitude and the latitude. And we have 5 also, in this implementation we use a 5,913 US city with more than 5,000 population, and this is the evaluation matrix that we use here. The first we use the accuracy, and we use the average error distance, and for the accuracy actually the successful estimation will be when the ground truth location and the estimated location actually less or equal to the threshold, which is here D, where D actually equal to 100 miles. And this is the baseline result for 3 different models. And this is without using the local word selection actually, where the accuracy actually is around 10%, which is not that bad in terms of the location. So to improve this accuracy, actually, as I mentioned, we propose to find the local word selection, and this is the result based in the local word by using the Gaussian matrix model, where the accuracy actually reach almost the 50% by using the 2,000, the top 2,000 word, also with different management here. And this is a correct example of estimation this city based in this kind of tweet. So this is as conclusion actually for this dissertation. First actually we have highlighted the need of the social user mining research actually with the growing number of social media data, and also we have pointed out the unique characteristics that the for different social media data, and this data actually has bring with it an interesting and challenging research issue to be resolved. And also we presented a novel mining method to for the social user mining based in different data type and also different mining application, as well as different social media sources. And also we propose a new method for data integration to integrate between the textual data and the visual data, and this is actually done through a semi-automatic tagging system. So as future work actually, first in this dissertation we have focused in terms of the attribute in two different attributes, which is the location and the gender. So further study actually we can try to implement also another or investigate about another kind of attribute like the age, where we can group the user base in their age, and also to improve the social user mining research we can also use more